I first want to show you a mistake that you made within this problem and then show you um, uh, another mistake that you made. So first of all, going from here to the antiderivative. So I agree that the antiderivative of sine is negative cosine. However, you said that the antiderivative of sine squared is negative cosine squared, and that's not true. To see that's not true, just like here you take the derivative of negative cosine, you get sine. If we were to take the derivative of negative cosine squared, that's actually the derivative of cosine squared x is cosine x times cosine x. That's actually what it is. And so the derivative using the chain rule would be negative 2 cosine x times the chain rule, negative sine x. And so, like, this does not get you back to here. So one question is, what is the antiderivative of sine squared? Okay, and that is a process. I want us to come back to that. So I want to draw a picture of this problem. So you have negative 2, and you are rotating around negative 2. And here's pi. So let's graph 5 sine x. So 5 sine x at 0 and at pi equals 0. And then at pi over 2, the sine equals 1. So sine x is 5 sine x is 5. So our region is this, the region bound by that and that. So this is the region that we're rotating around this line. So like if we took it and we pulled it out of the paper, here's the mirror image of it down here. That's a bad mirror image, but you get the point. And so the idea is that we take a slice. So here's the slice, and I rotate it. So put your arm out. Your arm is negative 2, and then put your pencil here, a little gap above your arm, and rotate it around. And here's the mirror image. You get this disc, and it has a hole in the middle. And so we're looking to add up the areas of these discs, which is the difference. It's your pi, and then there's the area of a circle, the big circle, I'll call it big R squared, and we have to subtract the area of the small circle, which is little r squared. So really, the area that you're interested in, we're stacking up these discs. That disc can go from 0 to pi, and the area of the disc is pi. The big radius squared minus the little radius squared. From here to here, the big radius squared is what you have. I'm glad you have a +2. That's really good. But you didn't subtract the little radius squared. And the little radius is always 2 units. It doesn't matter if the washer is there or over here. And so we can see that actually this 4 that you have disappears. And so really this 4 disappears. So really we are looking at doing this. So we still have to integrate the sine of x squared. And that's not one that you should know off the top of your head. And there are different ways that I can show you what it is. I don't know if you're, I don't know the technique and I don't want to be confusing to you. So what I would look in is your notes and look for something like the antiderivative of sine squared or the antiderivative of cosine squared and see what your professor does in that situation. And if I can be of more help, let me know.